Gave you an extra 2 days to be nice to you. The 24 assignment, it's got how many phases? Six. Okay. Okay. So you're aware of this, and you're not going to be unpleasantly surprised when you find out it has 6 phases. So I would encourage you to start working on that. As I do say in the document, I think the subsequent phases don't take any more time than the first phase. The only slight caveat on that is Stage 5 may take a little longer, but not so much in your programming time. You'll find out when you unlock that level, you will learn what that means. All right, but meanwhile, back to class. Let me put the screen down. Okay, so last class we talked about this. We talked about how we could essentially build our own version of a new construct in the language, right, by using this kind of let transformer. And so if this is all the in bracket, but in case it were not, right, I could do this, I get an expression out, and then I can run eval on that to get an actual answer. Okay? But there's actually at least 3 reasons why this is a terrible way to add things to the language. First of all, as I said, you know, if I go look at this over here, I get all these nice arrows. Like, you know, Racket actually knows that X is this X over here. These are the uses of X, right? It's got all this information, and I'm mousing over here. Like, well, if I copy this code over here, right? I'll copy this code over here, and nothing, right? It's just data. It's like it doesn't show you arrows and strings either, and this is just like a string kind of thing. So that's the first problem, is I don't get any of the benefits of the programming environment. The second problem is, as I said, from a security point of view, eval is really bad because you think you've verified this program, you think you've checked that it doesn't have any security bugs, but then somebody comes along somewhere else and runs eval on something, and suddenly new code got introduced into your program that I never got to see, right? So in fact, it's a very concrete problem, by the way. This isn't some abstract statement. Most secure JavaScript web programming frameworks, the first thing they do is they get eval out of there. Literally the first rule of JavaScript, secure JavaScript web programming is you take out eval and you take out width. And then you start talking about what it needs to secure things. Right? So we worked with with multiple teams at Google on JavaScript web security, and that is literally the first ground rule. Everyone agrees on that when we walk into the room before we start discussing anything further. Right? So it's bad from a security point of view. There's actually a third problem. It's subtle, and I kind of alluded to it last class, but I didn't make it explicit, so I'll make it explicit. What is eval? Eval is a compiler. Eval is the compiler sitting around, but it's sitting around at runtime. Normally, you think of some evaluation thing, like a compiler is something running and producing a program, and then it can go away, but now it has to sit around, like my whole runtime system has to contain a compiler, and like, oh my god, that's just painful, right? That's just way more stuff to maintain and way more things that can go wrong. Okay? So as a language designer, I really intensely dislike eval. Right? It's there, it's useful, it's there for legacy reasons, but I'd really like to get rid of it and solve these other problems as well. Right? So if I can do this kind of thing, if I can extend my language without having to have eval in there, then I don't have to worry about any of these problems. Okay? All right. So how are we going to do that? So now I want to make a comment about sort of language design philosophy. Hey, what do language designers do? What do language designers do? What do language designers do? What do we do? I mean, computational biologists solve computational biology problems, right? I guess they go off and they think about, you know, finding gene sequences and so on. What do networking people do? I guess they make networks. They make networks faster, maybe more robust, more reliable. Algorithms people invent algorithms, obviously. Whether you need them or not, they'll give you a new algorithm. PL people make languages, right? And but how do we make languages? Like, one thing we do is obviously we argue about syntax. Right? So what is pirate? Pirate is roughly Racket with a syntax that some people like more. So we argue about syntax, but actually I would argue that what PL people really do is we look for things that are painful and find ways to make them not so painful. That's the essence of what programming language research really is about. Like finding more and more interesting ways of writing programs and making them less painful and more reliable and more robust. And depending on how long these lectures take, I might show you some, I'll try to show you maybe some cutting edge stuff that's happening around like writing. Like imagine preview. Imagine if, remember you did say, let's go back to balanced binary search trees, right? That's a pretty strong property. And we talked about how you could write percentage and write a little property for it and get it checked at runtime, but then you want to turn it off because at runtime it's constantly going to be checking this stuff. Imagine if your compiler could tell you if you wrote a program that didn't actually produce balanced binary search trees. Like you couldn't even run the program. Your type checker would prevent you from running such a program. Right? And statically, before you can even run the program, tell you, nope, you got it wrong. Right? So just imagine if every assignment in the semester, every algorithms assignment in the semester, you could, just like in Pirate, you have a type check button. Imagine that when you click that type check button, we don't have it in Pirate just yet, but I can show you maybe other languages, where you click that button and it won't even run your program because it's telling you, you didn't satisfy the homework problem, right? You got your assignment wrong. So you don't have to turn it in and then have the TA tell you got it wrong. You just find out from your compiler, from the type check button, that you got it wrong, right? That's where language technology is headed right now, right? Because that's how we're going to produce sort of the next generation of more secure systems. So part of that is being able to extend our language when we need to, adding new constructs to the language as we discover new features that we need, instead of having to go to the compiler writer and say, hey, would you please add this to my language for me? Saying, we can just add things to the language ourselves. That's essentially what we're trying to do here, okay? So I'm giving you a trivial example because it's a nice illustrative example. It's not like a pressing need that we have. But there are many, many more interesting features that you could add this way, and I might try to show you some of those later. Yeah?
How do you add like that algorithm / data structure checking feature without losing like generality in the language? Like,
it's a complicated question, yeah. So 173 is a good place to talk about those things.
Right.
Yeah. Okay, so for now I have a much more trivial problem, right? Which is how can I add this feature and still get all of the benefits of Dr. Racket? So let's go back. I mean, this is what I had as a comment, right? What I'm essentially trying to say is, like every time you see one of these things, turn it into one of these things, right? That's essentially what I'm trying to say. So essentially I'm trying to tell Racket, please define a new piece of syntax for me called mylet, right? And I need to tell you what the rules of that syntax are, right? Every time I see one of these things, turn it into one of those things. That's what I'm trying to say. And it turns out I can just say it. I just added that. There's no eval anywhere. There's no quotations anywhere. There's no strings being done anywhere. I just wrote something there that looks exactly like any other thing in the language, right? It doesn't look like a special new thing. There's no quote markers around it. I just wrote code like I always write code in the language. And this magical piece of syntax here, there's a few things I need to explain here, but this magical piece of syntax basically says, add a new thing to my programming language. Not just a new function, but a new kind of syntax in my language, right? Notice, is that a function there? Is mylet a function? Talk to your neighbors and come back and tell me whether you think it's a function. Like either yes, it's a function, it could be a function, no, it can't, like yes, it's a function, no, I don't know, but it could be a function, or no, there's no way it could possibly be a function. Go.
So mylet is just mylet.
But otherwise we're trying to evaluate the argument that one has like that.
5, 4, 3, 2, 1. We're back. So, function, not a function. Could be, not sure. 3 possibilities. How many think it's a function? How many think it could be a function, but you're not sure? How many of you are sure it's not a function? Not a function. Who's sure it's not a function? Okay, that's I like confidence in someone so young. Yeah.
I'm looking at how it would evaluate its parameters if it were a function.
Ah, so if it's a
And
function, it's going to
applying
evaluate its parameters,
Yeah.
right? So what's going to happen? That term there means x is a function that I'm going to apply to 3. Is x a function? What is x? What is x? What is x?
Non-bound identifier.
It's an unbound identifier. So if I say x applied to 3, what's going to happen? It's going to come back and say, what's x? So if I say mylet, so let's say I say, I'll misspell it as my 2 t's, okay? X applied to 3 plus xx. It's going to come back and say, well, that's not defined. But even if that were defined, so let's try defining this as a function then, okay? So let's say define mylet of a and b, okay? And I don't even know what it's going to do. Let's just say it returns 3, okay? Let's not worry about what it does. So I do that, and now I say mylet of x applied to 3, and it comes back and says, I don't know what that is. Because functions evaluate their arguments. So it's going to evaluate that argument and then evaluate that argument. When it tries to evaluate that argument, it's like, okay, that's another function application. It's something x applied to 3. What is x? Well, I don't know what x is. It can't possibly be a function. It's truly a new piece of syntax because it's introducing a new variable binding mechanism into the language. Just like lambda can't be a function. Because the whole point of lambda is when I say lambda xx, that's not the application of x to no parameters. That is, please make that new name visible in the body. The same way, let is that x, it's not previously bound, please make it bound inside that body. So if that were a function call, then it couldn't possibly do that. It could only do that if x is already bound, but its whole job is to make x now a thing that has a value associated with it. Does that make sense? All these things aren't functions. They can't be functions. And so if the only thing you can add in your language is functions or methods, you can't define new pieces of syntax in your language, especially if the whole point of the new syntax is to do something that you couldn't previously do. That make sense? Okay, so this, on the other hand, works just fine, and I can say mylet of x to 3 plus xx, and I hit return, and I get back 6. Okay? But notice something else. It does the same thing that did up over there. Right? So by adding this new syntax here rather than using eval, basically the programming language now knows about this new construct the same way it knows about the built-in construct. And that's because the built-in construct isn't actually built in. There is actually a rule that looks exactly like this in a file sitting somewhere on the file system. That is how Racket learns about what let is. It doesn't know let either. The base Racket language does not have a let construct. That let construct was defined using exactly this mechanism. So once you provide this general mechanism, you can make your own new syntax, and your new syntax gets all of the same privileges that the built-in syntax does. Now, most of the languages you have programmed in before, in fact, I'm going to venture a guess, all of the languages you programmed in before, with very small exceptions, you couldn't even add new syntax to the language, right? But what I'm showing you is a way of adding new syntax that has all the same power as anything built in. It has no additional privileges when it's built in. And in fact, it's not built in, it's built using the same thing. So let me show you a little bit about what actually happens here. If I run this, right, it's going to produce 6. There's actually a cool tool called the stepper, the macro stepper, that shows me what's happening inside the programming environment. It's really complicated. So let me go to the end and try to show you what happened. That's what actually happens inside language. So what you really need to focus on is over here. It's saying apply a lambda where lambda x plus x is applied to quote 3. Okay, the rest of it you can ignore, right? But that's the rule that we taught it, and it's executing that rule and showing you how that piece of code gets expanded, and then this expanded code is the code that actually runs inside. So it turns out like this is what a module what that file turned into, right? And every one of these details has some relevance here, like what's it doing? It's keeping track of source locations, it's quoting things, interesting stuff going on, like error reporting. It's all of that mechanism is revealed. Okay? Okay, so let's go back to let for a moment. Okay? I can also say something like this. Actually, let me do a new thing. Okay, how about this? Remember and or? And or, are those functions? And or, are they functions? Talk to your neighbors. Oh, well, so here, and true, false.
Oh, yeah.
It's false.
Like even
Oh, but like, yeah, no, it's
Automatically, and this is
well, and also you can put like a value. I think in general, I think and or are
yeah, because you can't go and
like
X plus
well, it's I think they're it's in
yeah.
and that bracket they act as very much functions, but
Okay, 5, 4, 3, 2, 1, we're back. And or, functions? Functions? Anyone disagree? Wow. Okay, so let's try this, okay? Let's define x to be 0, okay? Actually, here's a simpler example. How about I say or true, false? What do you expect that to be? Okay, it'll print it as hashtag T, but it's not hashtag, man, hash. It's not a hashtag, that's not a social medium there. It's hash, okay. So, true. You can vocalize it as true from now on. Okay? Okay. What if I say, what am I going to get?
error.
True.
Depends on how it's implemented.
Okay, how about this? What's that going to produce? Why? It's called short circuiting. We talked about this before, right? So and or look as long as they need to make a decision, and once they made a decision, they don't need to look any further. Okay? Now you could argue maybe that's not how programming languages should behave. Maybe they should report errors, but that is how most programming languages behave, and it turns out for somewhat good reasons this is not a bad thing. Okay? So what does this example teach us?
Not a function.
Why not?
Because a function would evaluate.
It would have evaluated its arguments, right? So if I had instead said, define my or A, B, and said something like, if A, then what? Produce A, else produce B, right? So if I did that, and I said my or of, what was that? My or of that, it's going to come back and say that. Whereas if I say that, it doesn't. Can't be a function. Or isn't a function either. Okay, so how could we, let's say you come up with a new Boolean connective tomorrow, or a new operator tomorrow, and you would like your new function, like thing, to also short circuit. You can't implement it as a function. Okay, but instead if we define syntax, okay, my or of AB is, if A is true, then return A, otherwise return B, right? And now I run this, and my or does the same thing that or does. Okay? Because this is run before your program starts to run. It takes your program source and rewrites it to new program source. These things are called macros. And what macros do is they rewrite program source to new program source, and it's the rewritten program source that is then fed to the rest of the implementation. So when Racket starts to run, it never even sees my-or. All it sees is ifs. Okay? This is the primitive construct. This is not. But from Racket's point of view, it doesn't care what you built on top of it. My-or of AB turns into if A, then A, otherwise B. And okay? So it's kind of like the function that we wrote, except it's now working in terms of the syntax. Okay? Yes?
What makes like defining syntax more secure than a val?
Because, first of all, there is no eval. Okay? In this program, right, I know all of my programming constructs. In fact, as the person building the Racket analyzer, I don't even need to know about the existence of my-or. I only need to know about the existence of if. When I compile this program, when I say produce a binary for me, right, which I can do in Racket, but I'm not going to bother with that. When I say produce a binary, all of the, so this code over here, okay, gets translated for me, and this is actually what it gets translated into. Okay, so if I go to the last step over here, if I go to the end, okay, so I can go backward and see how it produced step by step by step, how it produced all of that code. But if I go all the way to the end, this code is what I actually see. Okay? There's no eval in here. The important thing is, as I run this program, no new code will get introduced. That's the critical thing. If I've analyzed this program and bless it and say this program is okay, no new code will get introduced when I run this program because there's no eval in here. If one of these things have been an eval, all sorts of new code get produced that I don't know about. And this isn't a hypothetical. In fact, one of the ways you can attack websites is websites create what are called sandboxes. And the way to attack a sandbox is you sneak an eval in there. So the sandbox looks at the code and says, yeah, this code looks pretty safe. But then you sneak the eval in there, and all of your malicious code is snuck in through the eval, and now it gets around the sandbox. So in fact, the whole game in web sandboxing is checking for all of the places that might be an eval and preventing the eval. And then you secure the code by checking that it doesn't do bad things. Okay? So there's no evals. Nothing at runtime, no new code is generated. I don't even need a compiler to be present at runtime. With eval, that's, you asked, remember last class, somebody asked me, what's eval? It's like, it's the compiler running while your program is running. Right? So that actually means if there's a vulnerability in the compiler is sitting in the runtime system, and so I can use the vulnerability of sneaking into the runtime system and breaking something. Here, there's no compiler anymore. Okay? Okay. So I get the benefit of new constructs without having to worry about the pain, right? And it says, okay, where's my or? This my or is my or over here. It's not the or from Racket. Okay? So far, so good? Yeah?
What are the open and close parens in syntax rules?
It's an advanced feature.
Okay.
We won't need it. Okay? Okay, good. So, or, we know how to do or, right? We can say or, true, false. Actually, I can actually write or with 3 legs as well. Right? If I say or false, false, 1, it's going to come back and say the last of those. It's going to come back and say 1. 1 is considered a true value. Everything other than false is a true value. Okay? Can I do that with my or? What do you think happens when I hit enter now?
Syntax error.
Why?
Because you've defined syntax with only 2.
Yeah, this is a 2-armed or. Okay, so that's not hard, right? So now you can see why there's, so I have an A, B, C. So if it's A, then I want to give A. Otherwise, I actually want to just say my or of B, C. Right? Okay, so now if I do that, that works. Great.
Another branch.
Hmm?
Another branch.
Another branch, right? And then eventually we'll exhaust our test suite and then we'll be all set. Or maybe we should do something else. Maybe that wasn't the thing we should have done in the first place. Okay, let me ask you this. What is the smallest number of things OR can take? One? What is the OR of just one thing?
Or an and.
It's whatever it is. It's whatever that thing is. Can you take fewer than that?
You have a default.
Okay, let me ask you this. If I ask for just that, what are the possible answers? Error? True? False? 17?
I know it is.
How do you think there should be an error? How many of you think it should be true?
Oh, this is.
Okay. How many of you think it should be false? Why false? Yeah.
Because false is the identity.
It's the identity. If you want a fancy word for it, it's the identity for OR. Okay? Basically, you want to think of, whoops, I shouldn't be editing on the wrong buffer. You want to think of OR of A, B, how do I put this? If you combine, so look at what we did here. We said OR of A, B, C is if A then A, otherwise OR of B, C. Okay? So we could make this even simpler. We could just say OR of AB is, what we're really trying to say is this, right? It's as if we had like a dot 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 here, right? Like we have more things there. That's like saying, so I'm just going to write code, I'm just going to make up syntax here for a moment, okay? It's as if we had my OR of something like that, right? If A is true, then A. Otherwise, my OR of the rest of the things, right? That's really what the definition of OR is for a multi-armed OR. But supposing there's 0 things there, what should we return? We have to return false because nothing was true, right? So if there is nothing to begin with, then nothing was true. Otherwise, nothing was true. So really what we're saying is my OR of nothing is false. Otherwise, we're going to do this sort of recursive thing over here. Okay? I don't see any pink on my screen. So my OR that's actually perfectly legal syntax. The dot 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 is part of the legal syntax, and dot 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 means 0 or more of the previous thing. Okay? So this means there's a first thing and then 0 or more things. And that means you're going to check the first thing, and then if it's not first thing, then it's whatever the value of the first thing is. Otherwise, it's all of the remaining things. This is just list recursion. But it's list recursion over the syntax of your program rather than over a list at runtime. Right? So base case, recursive case. So this is empty and this is link first and rest. Yeah.
So when you have my or A, B, dot, dot, dot,
Yeah.
and then you call my or of 1,
Yeah.
it still works. So does that mean
So let's see what happens in my OR of 1. Is it my OR of no things? No. So what is A bound to? 1. What is B dot 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 bound to? Empty. So this turns into if 1, then 1, else my OR of nothing, which is false. Yeah.
So the syntax isn't just dot, 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 it's B dot, dot,
It's
dot.
really B dot dot dot. It's really B dot dot dot. Yeah. And I'll show you a more interesting example of that in a moment. Yeah.
Just wondering, can you write macros with macros?
Yeah. There's syntax rules is actually not primitive in the language. It's actually a macro over something called syntax case. So yeah, there's a more convenient way of writing the more sophisticated form of the macro. Yeah, obviously, yes. Question? Do you have a question? There was another hand up there. Yeah.
Previously, but it was into.
Okay. Yeah.
So do we necessarily need the B? Because it doesn't seem like it's doing much.
Ah, do we need the B? Well, it depends on what the meaning of dot 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 is. Dot 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 means 0 or more of the previous thing. So this, if I took out the B, this would mean 0 or more cases, right? This is, look, just think in terms of this is cases. cases of list, empty, link. A is the first, B dot 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 is the rest. And that could be empty. 0 or more things in the rest. Questions? Yeah.
Does there have to be a value for B?
Sorry, sure. Hey, guys. Sorry?
Does there have to be a value for B? Because like, if you only did like my or false, like what would happen?
Let's see. So my or false, right?
Yeah.
So false, so it's not this case.
It's not like,
So it's this case. A is bound to false.
yeah.
B is bound to the empty sequence.
Oh,
Okay? And so that's going to turn into if false, then false, else my or of the empty sequence, which is also false, and so you're going to get a false either way. But you're going to get a false for this reason, not for this reason. Yeah.
If you pass a list of things in, does it treat it as a list or?
No. These are not runtime lists, right? These are
I
syntax
know, but if you
lists.
pass a list in, as an argument.
Oh, so my or of list 1, 2, 3, you mean?
Yeah.
Like that. Well, a list, any list value is true.
Okay.
So that's just going to come into true, but it's going to come back as a list, right? It sort of gives you the true value that actually, because there could be many true values, so it gives you the true value. Okay? Good. So now, again, my or works and everything works, okay? So now what we've seen is we can actually define sort of more interesting syntax. That's actually kind of true of let as well. If you do let, you can do something like x is 1, y is 2, z is 3, plus xyz. And if I run this, all of those things are bound, right? X comes from there, y comes from there, z comes from there, right? But my let seems to allow only one variable versus let allows you to have any number of variables you want. Think about it for a moment. Go, talk to your neighbors and tell me how you'd modify my let.
You'd have bracket A, bracket X, B, dot, dot, dot. No. You'd have an extra. You let,
We're keeping our parentheses as a syntax.
you have let with zero.
Because it has to be it doesn't have to be, maybe it's not.
They put the basic these like look at
You're
the
not,
A, B, X,
you're not evaluating
just
against
evaluating.
just using
Or just
Yeah, you need a basic answer.
Yeah, I don't know.
I don't think it's recursive.
I think it's just a matter of what you're doing.
You're not recurring, there's no base case for let.
5, 4, 3, 2, 1, and we're back. Okay, so I heard the R word battered around. Like, is it recursive? Is it not recursive? So, essentially what we're trying to say is we have any number of these that we want, right? And we want each of the x's. By the way, you notice, by the way, it's giving you an error. It's saying missing an ellipsis without a pattern variable at x, something like that. What it's saying is x was under an ellipsis over here in the input. It's not in the output. Okay? And so now I can just delete this and say my let, and it works just fine. And in fact, it's giving me the same arrows for a user-defined piece of syntax as it did for the built-in syntax, right? So what this is saying is I have 0 or more xv bindings, okay? 0 or more, so it means I can also have a 0 bindings. And I want in the output, I want those x's in the same order and the v's in the same order, and then it just does exactly the right thing. Right? Like, essentially what happened is this was a dissertation of a person named Eugene Kohlbecker. He essentially noticed that what was happening is people were writing this kind of stuff by hand on paper and then translating it into all that quasi-code business that we saw. And he said, well, that should be the job of a language. Why is it the job of the human to keep translating? So we just went around the building and had a whole bunch of people write examples on paper, found the thing that they were all writing, essentially said, you're all roughly writing a consistent thing, which is you use ... to mean 0 or more of the previous things, and you sometimes put it in nested positions, so I'll just build a language that does just that. And so, like, this was my implementation of his idea in Racket, that just pulls out the ... and puts things in the right places. Now, you were pointing about what if there was a recursive version of this instead? That actually gives you a different construct. So, here's something you can't do, okay? I can't say let x be 3, y be x plus xy. If I do that, it says I don't know what y is because they were all introduced in parallel. Okay? But instead, I can say in bracket, I can say let star, and let star says do them in order, and let star is basically a two-line change of this, which is exactly the thing you folks were talking about. That is let star. So I get a slightly different construct, but that's I could build that as well. Question back there?
Oh yeah, I was gonna say, so before b dot 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 could just be nothing, so could my let just take nothing?
Yeah, exactly. So that would suggest that I can write this. That would be equivalent to writing lambda of no parameters, return 3, and apply it to no parameters. Congratulations, you just wasted a lambda for no good reason. Yeah. But yeah.
Yeah, I see why if you call my let with only one set of brackets, it would split the x and v. But in larger cases, how does it know to keep splitting them instead of with the
Yeah, I'd have to teach you the whole algorithm. I can't do that. I can't do that in the time I have left in today's class. Right? But yeah, it's a smart algorithm. Yeah. Okay. Okay. So now people were asking about the dot 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 and the previous thing. Somebody asked me like the previous thing. What I want to point out is you can actually write complicated patterns as the previous thing, and it looks for the complicated pattern. Just to show you what that means, take your question a moment. If I wrote instead, let's say I wrote 4 over here. Notice that that doesn't match the pattern anymore, right? Because the pattern is there are 2 things, and here there's 3 things, right? And if I wrote that, it would actually give me a syntax error. Okay? But if I take that out, I'm good. Okay? Question?
I know bracket generally doesn't care about what type of bracket or parentheses.
Yeah. It actually doesn't at all.
Right, so if you use a specific one in the syntax, it doesn't actually.
Doesn't care. I've actually been tempted to say that it should. But for historic reasons it does not. So I could have written this over here, and it'll work just fine. Yeah.
Can you put y list of 2, 4?
I'm sorry. Over here.
Yeah.
What do you want me to do?
Where 2 becomes list of 2 and 4. So it's still y is bound to a single thing. But this thing is like a different.
What do you think is going to happen now?
You can't add.
Yeah, it'll give me an error saying you can't add a list value. The contract violation is you gave us 2, 4 as a list in the second position. Okay. There's actually a very clever thing you can do if you want to put multiple things in there. It's called splicing, and I'm not going to show you splicing because it would just be completely crazy. So there are ways of doing that, but I'm not going to talk about it here. Okay. Because there's a more interesting point I want to make. I want to actually go back to my or, okay? I'm done with let's now. The point there was to show you can write those more sophisticated patterns. But I wrote something on the right-hand side, and I erased it on purpose because I wanted to provoke you and see if it made you think about something. Sneaky, sneaky. I asked you, let's ask the following question. What if I say print hi, right? What does that produce? Well, I mean, it prints hello, right? But actually it returns a value. Is that a true value or a false value? How do you know? Sorry? Everything but false is true. Aha! Can we test to make sure that it's a true value? How would we do that? Yes, I can say if, right? Then I can return 1, otherwise I can return 2. What should I get? 1. Okay, great. So the hi came from the print and the 1 came from the return of the expression, and that's why it's got different colors, because the output, printed output is purple, so you can tell it apart from return values which are blue. Okay? So far so good? Okay. What does this have to do with or? Why? Okay, let me ask you to do this. Talk to your neighbors for a moment and think about why I even showed you this. Go. What could I have been thinking when I showed you this?
That's like what? My or it's like words.
One word to be able to take in a function.
It's
not a function. Sorry. Something which is value. Yeah. It's just evaluating something. Then this will be off on the side, and then you're
Okay, in 5, 4, 3, 2, 1. We're back. Okay, why did I show you this? It's weird, yes. But let's ask the following question. If I ran OR of print high and false, what do I expect as the answer?
High. Whatever print high returns.
Okay, how about this? Let's say I did this. Do I expect to get an error?
No.
Why? Because print high return a true value. So what do you want to see as the output? You want to see high printed, right? Okay?
Return it. Or wait, can you print the thing that returns? Or just like assign it to a variable like that. Ooh, yeah, that's a good idea. Yeah.
So OR printed high once. That's what most of you wanted. What does my OR do? Prints it twice. Why did it print it twice? Because we said if A. So that turned into if print. But we didn't mean to evaluate it twice. We only, because like that could be some big computation, you're going to go off and run it. In fact, it's even worse. It may be that that computation has a side effect. So the first time it returns a true value, the next time you call it might return a false value. So now your OR is going to return a false value because it evaluated a true expression and evaluated it twice. Like that would be completely bizarre, right? That would be totally unacceptable. So what you really want to do is you want to say something like this. Hold on to the value. If the temporary is true, right, then just return its value. Otherwise, go off and do things, right? So now if I run this, what I get is only 1, okay? And I can actually see that over here. They call the macro stepper and step to the end, okay? So right down over here, I'll show you this later. It's a little complicated. So, okay. Something about this code should worry you deeply. Something about this code should worry you deeply. Yeah.
Even if print returned a false value, it would still print.
Yeah, but that's going to happen, right? It's going to evaluate all the arguments till it gets to a true value. So the print high is going to happen no matter what. Something about the code change I just made should worry you. I just introduced a name. What if temp was already being used in my program?
What if A and B were already being used?
Well, A is coming from here, right? Those are just pattern variables. But this temp is an actual piece of code. I'm taking your code and sticking a let temp around it, right? So, in fact, can you think of a case where temp might already be used in my program, where this could actually make my program go wrong? Let's say that I had let temp be true, okay? And now I say my OR of temp, no, my OR of false temp. What's that going to turn into? It's going to turn into let temp be the first expression. What's the first expression? False. So actually, so it's going to be let temp is true. Inside it is the my OR, which says let temp be false if temp, else my OR a false. Right? and my OR of false is, that's going to turn into false, right? So, that expression is going to evaluate to what? That expression is going to evaluate to what? It's going to evaluate to false. What do you expect this expression to evaluate to, though? Let temp be true, my OR of false temp.
True.
We'd want it to be true.
You'd want it to be true, right? Because it's all an accident of naming. What if I called it, TP instead? That name change shouldn't make any difference, right? Because TMP is just some internal implementation detail of my OR, right? It shouldn't be leaking out. Just like when you call a procedure, you don't worry about what the internal names of that procedure are, right? Like you just call a procedure and they pick whatever names they wanted, you pick whatever names you want, and everything's good. So this is a little disturbing. Actually, there's an arrow on my screen. It actually produces true. Right? Just to be clear, it actually produces true. It produces what you expect, right? And the reason it produces what you expect is because behind the scenes, it actually automatically renames things so that you see that temp over there, that's the temp that you wrote as a user program. The temp that the macro introduced got renamed to a new name automatically, and all of the uses over there got renamed as well, and so this temp over here is this temp over here, but the user's temp over here is completely intact. So it automatically generates new names everywhere that it needs to make new names so that it doesn't capture names from the outside on the inside and from the inside on the outside. So this is a process called hygiene, and so what you actually have here is not just macros but hygienic macros. And so the name choices that you make over here are completely irrelevant, and nothing you write in your user program is interfered with over there, nothing there interferes with the user program. So you get a true abstraction rather than just, oh, it's going to do some code rewriting and whatever happens, happens. So this is important because you'll see how macros in other languages, like C notoriously has macros that doesn't have any of these nice properties. Common Lisp has macros that doesn't have some of these properties. But these days, these ideas have now gone on to other languages. So programming languages like Rust have now adopted some of these ideas. And so now like Rust and Julia and Clojure and so on now have macros that have some or all of these properties because basically there's now schemers everywhere. You just don't know about it. Yeah?
For the languages that don't do that, how would you deal with this problem?
Oh, you have to make up a fake name. You're just going to have to make up a name and get lucky. There's literally, in fact, in some of these languages, if you write a nested macro, right, you can get lucky at one level, but if you use the nested macro inside of it, you'll end up capturing yourself. There's just nothing you can do. Yeah. So in fact, it's not uncommon in in old Lisp programs to find names like this, right? And just hope that nobody used it, except your macro uses it. So your macro inside your macro and everything falls apart. Yeah, like basically you did SHA-1 something, right? And you put SHA-1 codes effectively. Yeah.
Oh, okay. So that's kind of what I was gonna ask. Is like, is there some way to intelligently rename it to its memory address or something?
No, you leave the compiler do it. So hygienic macros do that for free. Yeah.
I mean, to defend common Lisp, don't we have Jensen to do this?
Yeah, we can talk about that. Yeah. We can talk about how sometimes a non-feature is created to fix a problem you should never have had, which is what you just said in a fancy way. Okay, good. Okay, so that's hygienic macros. Next class, I'll show you how we can actually do some interesting things once we have this machinery. Good. See ya.